I hope you have met with your group batchmate and you are performing the experiment simultaneously. Everyone, right? Yes, no? How many having the system currently with them for this lab? Raise your hand quickly, please. I have seen only 5, 6 only. Why? What about others? Others are not having system. Yes, yes, good enough. Please raise your hand. Those who are using currently laptop or system. Fine, sufficient enough. And you have installed with the CST microwave, right? CST Studio Student Edition. Is there with everyone? Fine. Okay. With this, let me start my experiment. And our today's experiment is to design a monopole antenna using CST Microwave Studio. And we are going to check its radiation pattern and how it works. You can put your hands down, please. Is my screen visible?
Yes, sir.
Okay. Okay, so actually we are going to design a monopole antenna, and monopole antenna is what? It's a structure which uses only one wire. It's one of the wire antenna. Sorry. Actually, monopole antenna is a structure where we have one wire only, and one of the plane which we use it's a ground plane for it, and it as the name suggests, mono means single, and the pole means is one wire. Like similar to the last time experiment which we have done, we have used two poles, and that we will consider later on that with the dimensions actually that what exactly the dimensions are there for a monopole antenna. But before that, let me start with yeah, monopole antenna design. So for this, what is the fundamental is that we have a pole. It means a structure made up of, consider this is the diameter of this pole, and this pole is on a ground plane. Okay, it is also metallic structure. This is also metallic structure, and in between this, I'm showing you the thicker one, but it's not that much thick. This pole, the important thing is this wire, which we call as a pole, is a cylindrical coaxial wire which we use, and the length of this wire, okay, it is LP, pole length, and this sheet which is there, it should be of L length. Now, what is the relationship between this is that the pole length LP is equal to L by 2. Are you getting my point? And this is square actually. So here it is L, which is L cross L. So we have a L cross L sheet, metallic sheet, over which this ground plane is there. We connect one of the terminal from this, another point is this pole, and then we use it for antenna. So we are going to design this monopole structure. Here, for a monopole antenna, this L should be what? L is dependent on its frequency 142.5 divided by F. So keep in mind, we are designing an antenna for a particular frequency. So this L should be for a monopole antenna. This is, we can say, it's a design equation. You must know this design equation before you design a monopole antenna. So it is L is equal to 142.5. So what should be L if I am using a frequency? For example, we want to design an antenna for 2.4 gigahertz. We have to design, or aim of the experiment is design a monopole antenna for operating frequency of 2.4 gigahertz and observe the radiation pattern 2D, 3D, SWR, excuse me. Hello, sir. Yeah, so you can see here that Yeah. Am I audible? Is my screen visible?
Yes,
Yes,
sir.
sir.
Yeah, yeah. So actually the design equation here said for frequency of 2.4 gigahertz, we have to design this. So if you divide this L, what will be the value of L if it is 2.4 gigahertz? So L will be, then calculate it, 142.5 divided by 2.4 gigahertz. So it is coming around 59 point something. So it is 60 mm. The length of this is around, or we can say equivalent to 60 mm, right? So we, because we took it the reference frequency, exact if we take, then otherwise 59.097 something like that will be difficult to take. So we took it 60 mm is coming as a L. And what will be the pole length? The length of the pole should be L by 2. So it should come, if I take 60, so it is L by 2. As I told you before, LP is equal to L by 2. So design equation says LP should be equal to L by 2. So that comes around 30 mm for an operating frequency of 2.4 gigahertz. The another important thing is R. What should be the radius of this wire? This R is governed by an equation 0.008. This equation you should keep in mind always, right? For monopole antenna, into C by F. Okay. So if you derive it from this, it will be equivalent to, yeah, you can put the value C. C is equal to 3 into 10 raised to the power 8 meter per second. It's the velocity of light. 3 into 10 raised to the power 8 meter per second. With this, and F frequency is 2.4. So if you put it, this value will be coming around 1 mm. Is this clear by now? Till now? Are you following?
Yes, sir.
Okay. So we have a pole, a solid filled pole. We have to make a cylinder. Okay, that represent a pole. And then we need to make a base here. And then after we have to give connection. So we have to make a hole also, right? I'll talk about this later. So shall we take this? Shall I go for my CST Microwave Studio now?
Yes, sir.
Okay, so let's open a project. Simultaneously, everyone who are having system, please do it. The first notification of student edition, yes, okay. Go to this, it will ask for template. Go to the template. You people are having a class also today, right?
Yes, sir.
Yeah, yeah. Actually, about this class, I will let you know. It will be adjusted. So probably I will let you know which class I'm going to come. Uh, what will select? Antenna project, antennas. Go to next. Which antenna we are designing? Wire antenna. Select wire. It is quickly review of the last steps also which we have seen in the last time. Anyone having doubt? Go to next. We are designing a thick wire, so go to time domain continuously. Same thing. Next. These are the dimension it is showing. We are not changing these parameters because these are the by default equations, by default units. So no problem. If you want to change, we can do it. But because we have your units in mm, we have seen just now in design. So no issues. We are going to design it for gigahertz. So let the frequency be in gigahertz. Next. Frequency minimum. Now you see we are going to design a frequency for 2.4 gigahertz. So at 2.4, what will be the behavior? We have to check the behavior from the less than that value. So Let me say I am defining the frequency minimum from 1.4 gigahertz to 2.4 gigahertz I want to see. I want to check E field, H field, far field, power pattern and power loss, everything, no problem. Here it is showing already 2.4 gigahertz. So automatically, if I don't change even, these are three values, 1.4, 1.9 and 2.4. It will show me the frequency for three. Let it be, no problem, because for three different values we will get it. My most important thing will be to check the behavior, it means the characteristics at 2.4 gigahertz. Any problem till now? We can also write as a 2.4 directly. That's not a thing, but I am defining it for all three frequency. But my design is wrong for the other frequency, right? So you can see 2.4 gigahertz we have designed. I will take the dimensions of only 2.4 gigahertz. Are you getting my point? Because if you change the frequency, L will change or not? Because L is equal to 142.5 divided by F. So if I define it for 1.4 and 1.4, it is not applicable. Actually, I am designing it for 2.4. So my antenna which I am going to design is of frequency design consideration I have considered for 2.4, but just I define it for 3. Let's see what should come at 1.4 and 1.9 also. So let me define only for 2.4. So this is 2.4 gigahertz. Is this clear? Because my design is for 2.4 gigahertz. Here you can name your project. Let me write it as a monopole antenna. Finish. You'll find a simple cubic structure will come. Initializing the application. Please interrupt me in between if it is any question you have, or if you face anything to revise once again, you can stop me, not an issue. Okay. Or the network discontinuity or audibility, any issue is there, please let me know in the middle of the class itself. So here what I want, you see, according to our structure, I want to make a structure like this. Okay, we need to have some orientation. Last time when we designed an antenna which is in an x direction, because our dipole was like this, like that we have designed an antenna, two cylinders, and we cut this remaining portion between this. So it was the direction of this, a cylinder, right? But now I am designing an antenna. For this case, I need to do it this thing in this direction. So let me say it is y direction. Okay. Let me see what are the coordinates shown. Control H. So you can see here in the screen coordinates. Can you see the coordinates here in the right side? Y is upside, X and Z is the direction of the cube like this. This is X. Is it visible? Screen visible, right? Screen is visible to everyone. So you can see from
Yes,
this
sir.
center, I have to design an antenna. So in this cubic structure, let me show you in a wider view here. You see this cube structure. In this cube, this is the center. Okay. In this cube, from this center, this axis, you can see a gray line here. So I want to organize my cylinder exactly at the center. So orientation is where? It is the orientation. It is the orientation actually, you can see. Okay. Y is in this direction, Z is in this direction, and this thing. So orientation from center. Here I want to choose from this center a cylinder. From here, here is the Y, it is X, and this is Z. From this orientation, so everything 0, 0 is the coordinate here. We can say 0, 0 coordinate is here. With this, let me start now a cylinder. So I'm taking, go to modeling. I want a structure which is cylinder. So I chosen a cylinder. Go to center escape. Now you see Y direction we are designing. So here you first select your Y. And it is pole I'm designing. So I'm writing here is pole. What is the radius? It's a filled solid render. So what is the outer radius came when we calculated? Anybody can tell me? Radius came for this frequency 2.4 gigahertz. 0.008 into C by F when we did it, how much it came? Are you noting down? How much was the radius? Radius 0.008 into C by F. Put the value of F is equal to 2.4 gigahertz. C is 3 into 10 to the power 8 constant. So with this it comes 1 mm. I told you or not? There is no response. What happened? Can you hear me?
Yes, sir.
Then why not responding? This radius of this cylinder should be 0.008 into C by F for monopole. So that is C by F, put 2400 megahertz, or we can say 2.4 gigahertz. You will get the value as 1 mm. So from this, what I'm doing here is I have to make a cylinder. So with this, I chosen this radius as 1 mm. Any problem? Outer radius of the cylinder. And this is X center. Now you see X, it should be 0, 0. We want to center it at the exactly at the top, at the middle. And Y minimum, what is the length of the cylinder? Length of the cylinder? What happened? Why you're not responding? I'm not getting.
Sir, 142.5, sir.
Yeah, 140.
Yeah,
No,
142.5. 60 mm, sir.
60 mm, right. So 60 mm should be the length. It is L. It is for L is for this. Why you're getting confused? Just a minute. L is this one. So length of the pole is what? L by 2. Isn't it? So if 60 mm is L, then LP is coming 30 mm. So we want from 0 reference. This is our X, no? This is Y. This is X. And this is Z. So in this case, we want from here, what should be the X minimum? Y minimum? It is Y direction, huh? This is X. This is Z. So for Y minimum should be 0 or not? And it goes up to what? 30 mm. So we want 30 mm. So that's what we are going to do here. Here X is center 0, no problem, because in X direction nothing is there in for cylinder. Okay, diameter we already took in the Y direction. Diameter we took already, which was in X direction. And here we are going to do X center is 0, Y minimum is 0 to minus L by 2, or we can say, sorry, 0 to plus L by 2. We want to go upside, not downside. Are you getting me? So we'll say 60 by 2, L by 2. Is there any problem? I'm directly writing the value, so it won't ask me what is L. If I don't write here, I can write it as a L by 2. Any problem? Component I am choosing PEC, perfect electrical conductor. No problem. Let me preview. In the preview, I got a cylinder here. I can do OK. The pole is ready. Okay, with this pole, we'll go to components. I want to show it to you. So I'm going to pole, right side. Let you have a assigned material color. So let me write take a color here as a something which is clearly visible to you. So let me take as a metallic color here. Okay, so here we can see our cylinder is there in the x-axis. Can you see in this cube where it is, where we created, right? You can see, right, everyone?
Yes, sir.
Okay, now
Sir, can you again say how to assign a color, sir?
just go to component which we have sent, right click here in component, and here assign material color. Can you see, right click? Go to component, select the
Yes, sir. Yes,
component,
sir.
assign material and color, and here downside there is a color option, right? So we can see it clearly because gray and sometimes visibility issue is there. That's why. Okay. Now here what I can do is same material is there, same color we have assigned. Okay, stop it. Let me zoom it and see. Yeah, my cylinder is there. Center. XYZ. Okay, fine. Now I want this to be a plate below this, and the plate should be, there should be a brick. So select a brick from here. You can see there are options. A brick, because I want a plate or a cuboid, a cube shape as such, L cross L, and the thickness of this cube will be 0.02. There is a formula for this also, but we are taking this as a cube structure. Go here, xk, it is asking, let me write as a ground. It is ground plane. So I am taking the second structure in model, ground plane. What should be the x minimum for this? Now you see what I am designing. I want this plate, this should be, this is what is the x center, right? Exactly in the center. So I want this plane to be exactly in the center. Let me draw it here again. This is my a cube, not exactly cube, we can say it's a cuboid shape. This is thickness. This thickness we want to keep 0.02 mm, a small thick plate here, thin plate for ground plane. And this L is there. So L, and exactly I want, because already I decided the pole coordinate. So I want the pole should come exactly at the center here. So for this case, what should be there? I need to decide the length and width of this in a way that 0 is here and total length is 60 mm. So for total length 60 mm from this 0, it should be minus of somewhere from the center and minus of 30 here and minus of 30, plus of 30 here. Total length is 60. Can I do like that? Similarly here also, if you see from center here, because I want to orient this pole at the center, not at this corner. If I write it like this, okay, that this is from 0 to 60 plus direction only. In that case, it goes here. I want to center here. So when I center this pole here, from this also in this direction, plus of 30, minus of 30 and plus of 30 like that. So with this, here I put ground plane because the XYZ coordinate is there. In X direction, I want minus of 60 by 2. It means L by 2 to plus of L by 2. Are you getting my point why I did this? And the Y minimum, Y thickness should be 0.02 only, from 0 to 0.02 thickness. So if I do it upside, okay, then the brick which is going to create, it will go in the Y direction upside. It will, yeah, 0.02, 0.02. If I do like this, see the difference between this, right? Let me show again here. See, I am going to see the 2D of this. This is my plate. This is the pole. It is oriented at 0 in Y direction. Y minimum for this was 0 and Y maximum for this was 30. You remember when we made this pole? This is our plate. If I make the brick now with this position, that brick is thick. thickness where should I take? I take from 0 minimum, y minimum is 0 to minus of 0.02. Then I am going to downside. And if I wrongly take it as like this is 0, brick this is 0, and if I take it as a plus of zero point 0.2, then the brick actually shift here, isn't it? Because 0 reference is already the cylinder's bottom point, isn't it? So what we are going to do is we are going to design it exactly touching to each other. So for that we'll take upside. Okay. For minus point of view, y direction we take from 0. So we'll take it as a minus of 0.02 to 0. So then we can say it is already overlapped. We want this structure, not this structure. So for that, I write it here as y minimum as 0.02 minus. Any problem in understanding this? And y maximum is 0. In this case, what happened actually? The brick which is going to appear here, it has the thickness which is bottom thickness is at the, I hope you could understand. Yes or no? No. At least respond something. Yes, no. Let me show here, right? I have this pole length here. See in the 2D, right? Which we designed from y direction here was from y minimum 0 to 30, okay, in the plus, and this here the values are negative, y minimum, okay, this is the coordinate. Now the plate which I am making, its thickness is suppose 0.2 mm. So what I want is 0.2, what I want actually, if I am creating this thickness, and if I take the y direction of the thickness is in the y direction. So if I take this thickness in y direction 0.02, if I write y minimum for this as 0 and y maximum is minus 0.02, in that, sorry, plus 0.02, it goes up. Similarly, if I write for the thickness of the plate here that y minimum is 0 but the y maximum is minus of 0.02, the plate creates here, it means just bottom to this. Are you getting my point? Yes? Yes, no? At least respond something, anyone?
Yes.
Okay, fine. So here we are creating is a y minimum is minus 0.2. It means it is starting from up, going down maximum to 0. It means I want to overlap this. And z minimum is same, because in z direction also it is length. So I would say minus 62, 60 by 2 to plus of 60 by 2. Same material, same component. Okay, let me say preview. So if you want to see the preview, where the plate came exactly in the center, can you see? Yes, on the same plane. Can you see the 2D view? Agreed, no? So we got the plate exactly and the pole exactly in the center of this by this. Have we created the model? What is the date today? What is the date today?
10, sir.
We are answering the date, then why don't you answer? Did you get this? Can you see this structure?
Yes, sir.
Fine. So with this, here preview we have seen, let me do okay. So we have created a ground plane also, and same thing we'll do because the ground plane may not be clearly visible. So for that, we can go to ground plane, right click here, assign color. Here let me change the same because material is same. So same metal let me take, okay, done. Can we see now clearly? There is a ground plane and there is a, let me rotate this to show you how in the bottom side it is looking like. The plane, and yeah, it is the bottom side. So you can see we have created a pole and the structure. Zoom it. Is this fine to everyone after creating this? What we are going to do is now understand. Actually, what we want, let me make the bottom view. Bottom view is like this. Okay. And in the somewhere center, we have created a pole. Okay. Let me make it a bigger one. A pole is here, right? Which is connected. We want this pole has a diameter of sorry, not radius, not diameter actually. So we took it as a 1 mm radius of this pole. We want, and this is already metal surface, so we can say this metal surface is already covering this. It is the bottom view I'm talking about. So here what we want is we want to create a little bit more thickness. We want to create this hole in the ground. Here we want to create a hole. Okay. Okay. So for creating the hole, it is not visible from this side because this is also metal and the rod is of also metal. So we will make a hole here, and for making the hole, we'll make a circle. It means the same cylinder here, and the cylinder which will be there, uh, it should be having diameter more than the diameter of a rod. The rod was of 1 mm. So I want a little bit more than this. So for that purpose, for hole purpose, I will make now hole. And for the whole purpose, I will take the diameter, sorry, not diameter, radius is 1 is already there. So a little bit more I want. So I will take 1.1 mm of this blue color hole, right? And then after this blue color hole is also what? A rod is like this, right? Which is having a radius of 1 mm and a length. If I make a small hole which is having the small cylinder of which the length is 0.02 thick mm. Suppose cylinder having, I am making another create. I will create this thing which is 0.02 mm, and the radius is 1 point, sorry, 1.1 mm. 1.1 mm. Okay, so I have to create this small structure 1.1 mm of the radius, and the height is 0.2 mm. 0.2 mm, why? Because it is the thickness of ground plane. And if I adjust this thing exactly on the ground plane, what I can do is, this is my ground plane, exactly in the center, one point, or rod is like this. It means rod is of 1 mm and the hole is of this mm. I want to make a cylinder here exactly at the same orientation. And what I will do is, after that, I will subtract. There is a formula in here. What we'll do is, from ground plane, I will subtract the hole. Then what will remain? I will have a hole there. The rod will be as it is, and I will get a connection point between these two. Could you understand this concept? Could you understand this concept? Suppose you have a cake. Okay. Out of this, exactly in the center, if I want, take out a circular portion and make it so that you can see from top to bottom. Okay, to make this hole, what you will do, you will take a shape like this, a cylindrical shape like this, you will insert it here, and you will pull it out. You'll pull it out, then this hole will remain. Are you getting my point?
Yes, sir.
That's what we are going to do now. Okay. Just give me a moment. Hello everyone, welcome back. Let me take your first hour attendance now and then we'll continue with this. Okay, attendance please. Can you hear me everyone?
Sir.
Can you hear me? Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Am I audible?
Yes, sir.
Yes, sir.
Yes,
Audible.
sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Audible, sir.
Can you hear me? Am I audible?
Yes, sir.
Yes, sir. Audible.
Okay.
Audible, sir.
Yeah, fine. So let me take a attendance of the first hour then. We'll continue with the remaining part of our experiment. 5302
Present, sir.
5302 present, sir.
173,
173 present.
174.
74%, sir.
75%,
Please
sir.
continue in the ascending order. Yeah.
76 points, sir.
77, yes, sir.
78 present, sir.
79, absent. Okay. 85.
85 present, sir.
See, I'm taking the attendance in the real time. One time not spoken means submitted. Okay.
86 present, sir.
80. Okay.
87 present, sir.
Okay.
90 present, sir.
Okay.
94 present, sir.
Mm-hmm.
96%, sir.
98.
98%, sir.
99% sir.
205 present, sir.
213 present, sir.
217 present, sir. 220 present, sir.
223 present, sir.
225 absent.
225 present,
235
sir.
Then quickly, please. Okay.
231 present, sir.
235. Okay.
234 present, sir.
Okay. 35 absent.
235 present, sir.
Okay.
235 present, sir.
Okay. 237 absent. 238.
8 present, sir.
240
40.
present, sir.
42.
40 present, sir.
Quickly 43.
44 present, sir.
Okay.
50
50.
present, sir.
Okay.
52 present, sir.
Okay.
53 present, sir.
Okay. 54 absent. 55.
55 present, sir.
56.
56 present, sir.
60.
50 present, sir.
61.
61 present, sir.
63.
63 present, sir.
64.
64 present, sir.
66.
66 present, sir.
67.
67 present, sir.
68.
Yes, sir. 68.
72.
72, yes, sir.
73.
73 present, sir.
74.
74 present, sir.
75. 76.
76 present, 75 present, sir.
77. 80.
80 present, sir.
77 absent. Okay. 284. 285.
285 present, sir.
84 absent. 80, 91. 94.
91 present, sir.
94 present, sir. 94 present, sir.
95. 96.
95 present,
96
sir.
present, sir.
97. 98.
97 present, sir.
98 present, sir.
307. 308.
08 present, sir.
309. 311.
309 present, sir.
311 present, sir. 311 present,
313.
sir.
313 present, sir.
315 present,
315.
sir.
317.
317 present, sir.
323. 323 absent. So absent is in the first hour R. I'm quickly telling. 5179 absent. 5237 absent. 5243 absent. 52454 absent. Anybody on OD, please let me know. 5277, just one
Present, sir.
absent.
Sir. 52,000 present, sir.
Okay. 5284,
Yes, sir.
Krishna absent.
5284 present, sir.
Okay. Okay, and 5323. Okay, so only there are three absentees: Yala Sai Kiran, uh, Chandra Ogula Reddy, and Bathala Arvind. Sorry, one more. 5179 Raghavendran R. Right? I'm submitting the attendance. Any confusion? No. Okay. So first hour attendance is there. Second hour I will take at the end of this lab. Okay. Is my screen visible? Let me do quickly now what we want to do. Actually, we want to create a hole there. So for that hole, we will select. Could you understand the concept? We'll select a cylinder. Now, what should be the cylinder dimension? I will write this name as a hole. And then the cylinder, because I told you I want the cylinder to be exactly at 0. You know, pole be exactly radius was 1 mm. So I'm taking a bit higher, 1.1 mm of a cylinder, and then x center. What is the x dimension into that? Is 0. It means I'm x position is 0, and the y position which I'm taking is of 0.2 mm. So what I will do is I will take it as bit high, the hole to be at because it was 0 for this reference, so I want to cut it for z minimum was same thickness of the brick. Okay, so thickness of the brick, it was minus 0.02. Sorry, it is z direction it is showing. Oh. We need to see, I wrongly taken this y orientation, right? Now I will, okay. Y orientation I have taken now, and then can you see this? Any confusion? Y orientation we need to take hole cylinder at the y orientation, same, because cylinder 1 pole also be created on y orientation. So x will be the diameter we have taken 1 x center is 0, xz is showing xz is 0. You can see here this is our orientation, so let me make it like this. So in between xz, okay, so in between xz, it is center is 0 because there's the hole, because exactly in the middle we want to organize, and y minimum I am taking it as sorry for the interruption again. Okay, so here we want to create the hole. So y minimum direction should be what? We are taking y minimum. It is of the thickness of this. So I am taking it as a minus of 0.02. Are you getting this point? To 0. So that the portion which we created in cylinder, no, up to 0, that portion will be removed. Are you getting me? Yeah, so y minimum in the direction is 0 and y maximum in y direction is going up to 0.2. So 0.2 is the thickness of the ground plane also. So that's what we removed it now. Is that clear? So let me see the component here, preview. Let me keep the same component, preview. It is showing a small hole here. You can see. I can show you a bigger one in the preview. Can you see here this orange color shape which is coming a little bit larger dimension than this? I press OK. Any problem? Can you see a smaller hole in the same orientation I could create, right? Any question? I'm considering you are getting me. Please, if you're not knowing, let me know.
Yes, sir.
Okay, now what we are going to do is, okay, we want to, this hole which we created, this whole portion we want to take out. So for that, what we'll do, we need to keep in mind, I told you here that which portion from ground plane we want to subtract whole. So first select from which we want to select. So select ground plane as a number one. Then second is select Boolean. I will tell you here. Here you see, let me put it down somewhere here. Okay, now you see I'm selecting here ground plane first. I selected ground plane, and from ground plane here you can see in the same modeling option Boolean is there. Selected Boolean, and there is a subtract. Okay, it is showing me something on my screen. Select object to subtract from component 1 ground. So there is a mistake people used to do. Here you need to keep in mind, actually we want to select an object to subtract from, it is showing. So obviously we want to subtract from ground plane. A cake piece is ground plane, out of which a shape which you want to cut is the second object. Are you getting me? Are you getting the analogy? Cake piece is the ground plane. So obviously from ground plane we want to subtract the whole. So ground plane is already selected first. Let me do it again. Selected ground plane, Boolean. Sorry, I need to go to history and then I need to whole cylinder. Okay, nothing is done, correct. So selected ground plane, then Boolean, then subtract, and what I want to subtract? Whole, the whole shape which I have done. So I have done it like this. After this, asking press return to confirm or escape to cancel. I enter means return means enter. So if I enter now and see immediately in the right hand side of screen what happens if I enter now. See in the component list there what happens. If I enter, see the hole has gone. Could you see this? Could you see this?
Yes, sir.
Yeah. So we have removed the hole now, and actually now the road is visible from the downside. Let me see and show you here. You see, actually hole created by this. The whole shape which was there, no, it is removed. Can we see closely now? The hole is bigger than the solid. I'm trying to align it in the center, bottom side. Can we see here? Exactly from the center? Yes. Let me arrange this plane as a zero plane at the ground. And now zoom it from this. Can you see the whole size is bigger than the solid? Inside what we are seeing, no? If you can see the shape clearly, this inside one, this inside one, no? This inside one is a rod, which is 1 mm. From center, it is 1 mm. And the outer one was, because we took for the whole size, no? It was 1.1 mm. So actually we want a shape to differentiate between this. That's why we did it. So I took that shape out. So now rod is visible from downside. Could you understand the concept? Everyone? Yes. So now let me continue.
Sir,
with
can't
the
get that hole, sir.
next.
Sir,
Sorry?
How to come hole and plane, sir?
it's not
Sorry,
so.
I couldn't get your question. What is the?
Sir, we
What is
can't
not
get it, sir. Hole is not getting, sir. That after how to take that boolean, can you show, sir?
Okay, let me go back. Let me remove the history. Okay, because actually we want to show again. Na? In that case, actually, because I created, so you are up to the ground plane and this thing. Cylinder hole you couldn't define, right? That's the question? Yes. So let me define the hole again. Let me delete my steps. You need to actually delete and update. Then only you can show again, go back to the previous one. Delete and update. I deleted and update. I'm back to the same point where my only hole is not defined. No hole is defined currently. You can see in the history, ground plane is there, component ground plane is there. These two only defined. So let me do it again. Let me show a normal view. This is our upside downside. Let me downside. You can see all these options are there which you can use to rotate your plane, and you can practice it to adjust it, right? So I have hole and pole here, ground pole. Sorry, no hole is there. Sorry, pole and plane is there. So to define this, go to cylinder, and go add point and escape, because it's a new shape, na, and name it as a hole. Have you done it?
Yes, sir.
Have you done it as a whole? Okay. Now go to this Y position, because the pole which was there, na, that was centered from Y position. So it is the orientation it is defining. In a orientation, what is there? Y. In my scale, it is there Y orientation. I chose it. Is there any problem? No? Have you chosen the same orientation for your pole? Y? Then
Yes,
only
sir.
entered, right? Now here diameter, because I told you hole will be bit bigger than the pole, and the pole diameter was 1 mm. So I am keeping here 1.1 mm radius. Second is X center, it will be 0, 0 only. And the whole thickness, Y direction is what? Thickness of the sheet, because that much only I want to remove. So thickness of the sheet was from minus 0.02, because ground plane also I oriented like this, 0.02 to 0. So 0.02 mm of thickness, which was our thickness of the sheet, that I have taken and I have previewed. Did you see here? And then okay. So here you could see a hole came actually. So here also in component you can see 3 components are there now. One is ground plane, one is pole, and one is hole. Is there any problem up to here?
No, sir.
Can I move forward? Then after, what I'm doing is check it. See here, if I closely go, I can see my hole size is bit bigger in the ground plane, and this is my pole. So I want to remove this particular area. If I show you here exactly, actually this area, na, I want to remove this area, so that actually this whole complete area, na, from this will make a hole here, and the sheet from downside also will be removed. So this type of shape we want to remove. So what we are doing, this is our ground plane. Okay, I will take ground plane, select first, step number 1, select ground plane. So I selected ground plane. Okay, now what I want to do is, from ground plane, what I want to subtract? Hole. So ground plane is step number 1. Step number 2, go to boolean, and boolean here, subtract. Now it is showing select the object to subtract from ground plane, because ground plane I already selected before. This time select hole. Getting my point? Third step. First step is select ground plane. Second step is go to boolean and subtract. Then third is, it is when it is written here on the screen, that select the object, select here. Now it is showing subtract component which is hole from component 1 ground. It means subtract hole from ground. This is we want, isn't it? This is we want. If this is we want, yes or no?
Yes, sir.
Then if you want this thing only, enter. Once you enter, that portion will be subtracted. Can you see now? Let me remove this. What happened after this? Can you see? The hole is created. Any problem?
No, sir. Got
Yes,
it.
no?
No, sir. Got it.
Done? Yes, no?
Done,
You
sir.
put it done. Very good, very good. So let me with this. Let me now go to my project now again. Now we have what we used to do in the now model is ready. You can see downside. I can see this, and if I go to upside, there is a pole here, another side. So this side is the pole, because we chosen the same thing now. That's why it is showing like this. Let me put the pole of a different color. It's my choice, just to for the visibility. So let me take it as blue color. Okay, so now blue color is there, so I can see clearly there is a pole and there is a plate, and downside if I see, the blue color is visible, means what? Hole is there, right? You can see from this bottom, blue color is visible, means what? Hole is there. because blue color was for pole. So can I see now both the things clearly? Now zoom it as much as possible. Go to the boundaries. What you are going to do is, here go to simulation now, go to the boundaries, and here in the boundary you can simply write apply all boundaries. Okay, so actually we applied all the boundaries. And here in the pick point, okay, pick point, you can pick either edge, here it is showing edge or center of this. So here pick point, if you go, it will say pick edge center. Okay, so or pick end point, it's up to us. So a pick point on a circle. So let me select a pick point on a circle. Okay, I selected one point. Now what I'm going to do is, I selected a point on this circle, double click here, and similarly on the another circle, oh, it will not show like this, sorry, escape, go to discrete code, again let me go history, let me delete this pick point and boundaries, let me remove this, delete, yes, update, pick point on a circle, delete, yes, update. Whenever there is something happens, you can do this, no problem. Okay, again rotate, let me see the pane, it is the pane, and from this I want to select it. So for this, go to boundaries, okay, simulation, here boundaries, and let me apply all the boundaries. Okay, it is applied. Now go to discrete code. Simply you can, yeah, you can go to discrete code directly. And here in discrete code, you can select one and you can select two. Did you see my point? What I did? Could you notice this? And here the impedance, actually impedance for a monopole antenna is half of the transmission line, 73 divided by 2, which is 36.5. This is also parameter, please note down this. Important is L is equal to 142.5 divided by F. Important is the pole length is L by 2. Important is R is equal to 0.008 C by F for monopole. This is important, we should know this. Okay, here we apply and okay. Once I did this, and if I in between these two happen, you go to field monitor, automatically field we have selected, we in the beginning itself, go to setup solver, it is showing -40 dB, no problem. Here we can do is normalize the impedance, because maybe field impedance will be greater. So here you can select 36.5 and normalize the field impedance. Apply, start. So we have designed a model, we have selected two ports, you know, this one is internal, I selected two sub boundaries, one is 1 mm boundary of the pole, second I selected the 1.5 mm of, after creating the whole 1.1 mm boundary is actually selecting the ground. So actually we are taking 2 points out of this to connect it to source. What we are doing is, we are taking 2 points. That's what the fundamental is. Here, let me show you. After this is our ground, and this is suppose plane is coming. So we have to take one boundary of this for connection, and one is the boundary of this ground plane. So ground plane, I took this corner point here, and there is no connection between them. So one I selected pick center boundary, this one a circle like this, another one I selected the boundary of this like this. Both are not connected, in between them there is a gap of 1 mm, 0.1 mm, you know, because it's a 1.1 mm. Yes,
After discrete code, what this?
discrete port you have selected. Have you selected the ports? Have you selected those ports after this discrete port? Na, before that boundaries you have done. Discrete port, and then then discrete port will ask two things to select now. One cylinder on inside one cylinder outside one. Select them. Red should come 2 lines. Is it showing? Yes, no?
No, sir. Discrete would have to choose edge part, sir.
Let me show again. Wait. Modeling, history. Let me again delete all this thing to show you again. Discrete, yes. Delete all this. Define discrete phase, port, edges. Actually, delete, yes. Update, delete, yes. Update, edges also delete, yes. Update, delete, yes. Update, define boundaries, delete, yes. Update. So I'm there up to there when I made the cylinder. Okay. Now let me see again. We are in the modeling. Now we have to go to simulation. Go to boundaries. Have you gone to boundaries? Have you selected, applied all the boundaries in all direction? Yes,
Yes, sir.
no?
Yes, sir.
Okay. After that, go to discrete port, and here it will ask, see 2 lines are coming without doing anything here. It is asking here 2 lines. If I go here, it is red line. If I go here, it is red line, right? So I have to select, double click here, and then double click here also. Could you get my point?
Yes, sir.
There are 2 orange lines coming. In that, first time select this outer, both select it. Then it will consider 2 poles. And then after, here you mention the impedance as 36.5. Any problem? Let me know any problem. Have you
No, sir.
selected these two?
Yes, sir.
After that, because 1 or 2 point selection also actually making 1 port only. So no, it is correct. Nothing we are changing. Here apply. Okay. Then it will show a single line. Could you get my point?
Yes, sir.
After OK only, it will show single line. And then go to setup solver. And here just change the normalized impedance 36.5. Apply. OK. Let it run the setup solver. The answer will be available. I hope everyone is doing. I will ask for few screen sharing after this. Did you enjoy this practical? Isn't it interesting? Actually, after seeing the result, you will say it is interesting. If you have correctly defined model, then it will show the correct results. Any problem? Could you run your project? No response.
Yes, sir. Completed, sir.
So after this, you can see in the left hand side, the results will come, and let's see the interesting results now. Okay. If you go You can see in the S port signal, if we go S parameter, port 1 and port 2, says 1 and 1.1. It is showing, what is it showing? You can see it is showing 1. It means the 1 diameter. And 1.1 is 1.1 diameter. 2 ports we have selected, right? So at 2 points we have selected and both are port 1 only, right? S parameter, if we go, you see S parameter. S parameter results will be available here. Yeah, we can see here S parameter. We have selected a range of what? 1.4 to 2.4, isn't it? So as parameters are defined here, why it is not at 2.4? Reason being, you remember that L length which we have taken is not exactly 60, it is 59 point something. So it was coming nearby. So this is the S parameter magnitude we are getting. Go to, you can see all the results here. I'm not showing one by one everything. Here are so many results are there. Here, let's go for 2D result. In 2D plot, let we find. So it is E field return we are checking. E field. So you can see E field result is coming. I can see here. You can animate the result because its a source is connected. So let's go for animate the field. So can you see the field animation here? Can you see the field animation here? Go a little bit larger. Can you see the field animation here? 2 ports are there in between them. Yes, it is the monopole functioning. So we can say in between these 2 poles, this is a change. If animation you don't want to see, it's our choice. Next to that, if we go for 2D results, far field, go to far field and here select far field cuts. So in a far field result, what we are getting here, let it upload. It is calculating the values. You will find the polar plot in the far field. Okay. Not coming. I think we need to close it again. Go to this. Just a minute. 3D or red pattern. Okay. Maybe zoom. Normal fan. Yeah, we got this power plate, but actually this was bigger one. So let it go to normal one. Not efficiencies. Go to far field. Two D pattern. Could you see here a pattern 2D? Yes, it is the reference that for every angle, what is the radiation that we can see here. The polar plot is like this. It is showing a pattern like this. It's a monopole antenna radiation pattern. At some 90 degree and 90 degree, these angles at these 2 points, we can say it is reducing to 0. So we have got a null here, we got a null here. The maximum radiation is there. Here it is showing the direction of main lobe radiation, frequency. You can take this print out and show as a far field pattern. In 2D, if you want to see, it is a 2-dimensional pattern. In the scales, directivity it is showing. Radiation efficiency is this much. 3D pattern, if you want to see, yes, it is a 3D pattern. So we can say, if we check it in the reference XYZ, you can coordinate this and check this radiation. There are so many results will come out of this. Whatever is of your interest, we used to take that. So you can say this is how we created this in the same direction. What is the field? It is dBi. It means dB with isotropic radiator. Omnidirectional, linear directional, circular directional, Spherical results if we want, cylindrical scheme. Calculate. Could you get it, everyone? Yes, no? You can get the different E field, energy. Okay, VSWR values. This is the VSWR readings of this. E near field scans. This near field scan. So you can see in this structure, if you orient again in XYZ direction from the center, the field scans up to this. Near field is actually the range of up to which the radiations are available. So near field, what is it is showing? We can see field lines and radiation patterns for this. Different values of surface current if you want to see. You can maximize this and you can see this is the value of surface current. This we can check. We can, the readings are written in already in the screen of the calculated values, right? How many of you could do it? Any difficulty? Can you hear me? Anyone could do this? Very good. Yes, Sai Durga, can you share your screen, please?
Yes, sir.
Yeah, please. Okay, first of all, before you share the screen, let me take the feedback from every one of you. How many of you could understand? Please raise your hand. Raise your hand quickly. Very good, very good. I could see few only. Please do quickly, right? Very good, very good. So in this field pattern, now what you have to do, please note down this. In your laboratory, next week we are going to submit this lab report. In this, you have to design an antenna, monopole antenna for 3 different frequencies. Note down 1.4 gigahertz, 2.4 gigahertz and 3.4 gigahertz. You have to design an antenna and you know for all 3 frequency L value will be different. Okay, you have to design. Excuse me, listen to me. Yeah, so you have to design it for 3 different frequency and you have to compare the radiation pattern. It means polar plot of all 3, right? And you know if frequency will change, then L will change, whole length will change, whole length will change. So all 3 you change it, no issues. And then after you show the results of comparison of all 3 in the laboratory report. Take out their as the polar plot, take out the field, take out the S11 report, it means standing wave ratio, okay, SWR, VSWR report, and impedance, at least 4, 5 or 6 parameters of this radiations which you can show. Take the plot of radiation pattern and show me. So what is the assignment I'm telling you? It means the lab what you are going to include 3 different frequency. I designed only for 2.4 gigahertz. You have to design it for 1.4 gigahertz, 2.4 gigahertz and 3.4 gigahertz. Could you get my point? Any question? So I want a monopole antenna design and lab report related to this in the next week. Before the next laboratory it comes, I want this to be uploaded in the Google Classroom. Is that okay? Yes, you can show now. You can share your screen. Sorry, I couldn't see this. Share your screen once again, please.
Sir, is visible, sir.
It's coming up. Sai Durga, wait. Very good. You got the result as well. Yes. Very nice. That's what I want to see. So we have designed here. You have done exactly same what I showed you. You have to see the where we will get the polar plot in the far field pattern. Far field. Yeah. Go to far field. This is the field pattern. Yeah. Go to 2D. 2D. Sorry, 1D. 1D will come. Yeah, it is a 2D pattern we got. So you have to get it for 3. You can see right side written far field 4.4 gigahertz. So in the three cases which you will generate, it will be far field for 2.4, 1.1.4, 2.4 and 3.4. I want this for three different frequency. And similarly, in the beginning of the project, what you select the frequency range, take the frequency range larger, take from 1 to 5 gigahertz. In between that, we want to check that how our antenna is working. Is that okay? Thank you, thank you. Pawan is correct only. Okay. I expect everyone will do. Any question regarding this? Any question? I hope you enjoyed. Can you raise your hand? Who understood the concept to design an antenna?
Sir, what is the L value, sir?
Sorry?
L value for 1.4 and 3.4, sir.
You have to calculate, na? Formula is same.
Okay, sir.
Formula is same. 142.5 by F. Isn't it? Three design equations I showed or not?
Yes, sir.
Yeah. So from those equations, you can calculate. Okay, please raise. It will give encouragement to me as well. Please let me know because I'm first time teaching you people. So please let me know by raising your hand. You got the idea? Did you understand the concept? Good. One only. Anyone else? Anyone else? Anyone else? Great. Understood the fundamental. Okay. Hope everybody enjoyed, right? Fine. With this, let me take your attendance now. Thank you, everyone. Thank you, everyone. Let me take your attendance of second hour. Submit the lab report in time, everyone. Okay.
Sir, format, sir. What is the format for lab report, sir?
Similarly, what you used to have in all the laboratory, I've shared, I think, in a WhatsApp. Otherwise, I will share you a simple thing like including AMP first aim, then because we are doing it with simulation. So here requirement of our simulation, I will share for the practical one which I made. Okay, something about detail about the CST studio, and then after you'll start what is monopole antenna. Search in Google and write some theory, maybe half-page theory. It can be handwritten. It can be yeah. It should be uh, yeah, it can be any way. It's up to you which portion you want to write yourself, which portion you want to cut copy, no problem. But finally, the value you're calculating, it should not be copied, and everyone's orientation should be different, right? I will check it. Yes, certainly I understand that if you want to cheat, you can cheat, but if you are cheating, then you are cheating with yourself. So I understand that don't give your lab report book to other friends just for copying. Let them do it. Let them understand. If you're not helping actually by giving your lab report directly somebody to copy, you're not actually helping him. You are putting him into hell. So don't go into hell. Don't put somebody into hell, okay, or into a situation that they find a low resistance path. Let everybody do it and submit a good report to me. It will be a continuous evaluation, so it will be counted at the end also, and in a continuous evaluation also it will be considered. Okay, as and when finding some difficulty, some wrong activity, malpractices of the lab experiment conduction, report conduction, something I find, you will find me slowly. I need to be stricter, but I don't want to strict. I want to deliver the things in a right way, and I want you to learn and do it in the right way. Okay. Attendance, please. Quickly, everyone, start with the attendance. 5302 and subsequent
Present,
numbers should
sir.
quickly tell. Please. 171.
Sir, present, sir. 171. 173
I'm
present.
not for. Good.
74%, sir.
Okay.
75% sir.
Okay. 76 absent. I won't give much chances. One time only attendance, real time attendance going on. Okay. 77. 77.
77%, sir.
Okay.
78%, sir.
Quickly,
79
quickly
present,
next.
sir.
Okay.
85% sir.
Okay. 86 absent. Okay.
87 present, sir.
Okay.
90 present, sir.
Okay.
86 present, sir.
Okay.
96%, sir.
98% sir.
99%, sir.
205%, sir.
213%, sir.
217%, sir.
218. Sorry. 2220. Absent. Okay. Next. 223. Absent. 2 to 5?
2 to 5 present, sir.
231 present, sir. 2 to 3 present, sir.
Okay.
Sir, 225 present, sir.
Okay.
231 present, sir.
Okay.
234 present, sir.
Okay.
235 present, sir.
Okay. Please next 235 absent. Okay. 237. 237.
235 present,
Absent.
sir. 235 present, sir.
Okay. 237. 238. 237 is absent. 238.
238 present, sir.
Okay. Quickly next.
240
240.
present.
242 present, sir.
242.
240.
Okay. Please continuously tell 42, 43.
43 present, sir.
Sir,
243.
244 present, sir.
Okay.
244 present, sir.
250 present, sir.
Okay.
250
Okay.
present, sir.
Okay.
252 present, sir.
Okay.
53 present, sir.
Okay. 254. 254 absent. 255.
255 present, sir. Present, sir.
Okay.
255.
Okay. 256.
256 present, sir.
Okay.
256 present.
260 present, sir.
Okay.
261, yes, sir.
Okay. Quickly, please.
263 present, sir.
Okay.
264 present, sir.
Yeah.
266 present, sir.
Okay.
267 present, sir.
Okay.
268, yes, sir.
272, yes, sir.
275 present, sir.
272. 273 absent. Okay.
274 present, sir.
Okay.
275 present, sir.
Okay. 276. I am marking absent if you are not answering. 277. Absent.
77 present, sir. Present, sir.
280. Okay.
280 present, sir.
284.
284, yes, sir.
285.
285 present, sir.
291.
291 present, sir.
294.
294 present, sir. 294. Sir, 276 present.
295.
295 present, sir.
296.
296 present, sir.
297.
297 present, sir.
298.
298 present, sir.
301. 307. 307. Absent. 308.
08 present,
307.
309.
09 present, sir.
311.
311 present, sir.
313.
313 present, sir.
315.
Present, sir.
317.
317 present, sir.
323.
Present, sir.
Okay, so absentees are okay. 5176,
Sir, he
Present,
posted in chat box.
5186, 5186,
present, sir.
5186.
518, sir.
Why you are not
518
telling in the one
present, sir.
time? Next time I won't consider second repetition. 5220, 5220, absent. 5237, absent. 5254, Bathala Arvind, absent. 5273, 5273,
You posted in
5273,
chat
right?
box, sir.
Okay. 5276.
Yes, sir.
5276 present, sir.
Next time, take care. Tell in the first time itself. Okay.
Yes, sir.
That's it.
Thank you, sir.
Okay. So there are 3 absentees. Five two two zero, 5237, and 5254. Thank you. Thank you. Anyone there? Please let me know. No one. Thank you, everyone. You can leave the meeting now.
Thank you, sir.
Thank you, sir.
Thank you.